Hi everyone, welcome and good morning from here, good afternoon from here in Belfast, good morning from wherever anyone else is joining from. I'm Claire and I'm with the team here at Cloudsmith. Thank you for joining our webinar today. We're talking about something that is being showing up more and more in places, open source attacks. There has been various dependency attacks even in the last couple of weeks. So compromised GitHub repos, malicious NPM packages, and even VS Code extensions. The attack surface keeps growing and the tactics keep getting more advanced. So over the next 45 minutes, we're going to break down what these new attack vectors actually look like, and more importantly, what you and your team can do to defend against them. So to do that, I've got two great guest speakers with me today. First up, we have Jenn Gile, who is co-founder of Open Source Malware. Open Source Malware, for anyone who doesn't know, was designed as a community-driven threat intelligence project tracking malicious packages, compromised repos, and attacker infrastructure across NPM, GitHub, and beyond. So OSM has become one of the go-to resources for defenders trying to stay ahead of this stuff. And Jen's been right at the center of some of the biggest supply chain attack breakdowns this year. And another familiar face joining Jenn is Nigel Douglas. So he is our head of developer relations here at Cloudsmith. And Nigel spends his time deep in the developer and security tooling space. You'll maybe find him on Reddit, helping teams actually operationalize supply chain security instead of just talking about it. So welcome, Jenn, welcome, Nigel. Great to have you both here. Let's get into it. I'll pass it across to you both and you can do some quick intros.
Yeah, thank you, Claire. Great to see everyone today. I'm off on the west coast of the United States, as you maybe can tell from my accent. Happy to be joining Cloudsmith again for a webinar. So just a little bit about myself. I've been working in the open source tech space for close to a decade, between threat intel, as well as I used to work at Nginx, which I'm sure a few of you have heard of, part of F5, the US State Department. But these days, I am co-founder of Open Source Malware, and I spent a lot of time in the security community educating both security and developers about how they can safely consume open source. I'm a huge open source fan, and I want it to be safe and available for everyone. And also, as it says on the screen, I like bikes. I'm going to go ride my bike later, I think, after this webinar. Nigel, I'll pass it over to you.
Yeah, so I don't think I need to introduce myself for too long, but yeah, I work on developer relations here at Cloudsmith, primarily focused on enabling users, and so they understand the value of centrally controlling not just the software artifacts themselves, but also understanding what are the inherent risks in consuming open source. So yeah, we'll move on to the next slide.
Yeah, I think it's really helpful before we get into kind of the meat of this session to talk about vulnerabilities versus malware. But just, I guess, to set expectations for anyone who's joining us today, this is going to be a pretty casual conversation. Nigel and I are just going to talk about what we've been observing over the last now 8 months as we're into 2026. What's changed, what's stayed the same, what threat actors are doing. But to start with, a lot of people are familiar with the concept of a vulnerability in your software, a SQL injection or whatever the case might be that an attacker could potentially take advantage of to get into your application. And that is typically where we see vulnerabilities exploited, is to be able to, come in through an exposed application and then attack the organization in some way. They're typically have like what's called a CVE assigned to them. And I guess a good famous example, though it's dated at this point, is the log4j or log4shell. There's probably some more recent ones. You've heard about Mythos, perhaps, finding vulnerabilities in code. That is all to say, we're not going to talk about those today. What we're going to be talking about is intentionally malicious software components that were always meant to do harm, that if you consume one, it's not like a vulnerability where it's hypothetical risk and it has to be exposed through an application. With malware consumed through the supply chain, the second that you download it, it has the potential to, go boom. Many times they have shorter shelf lives on public registries. It's not like you're going to have or be aware that you have malware in your code for months or years. Yeah, so I'll take a pause there. Nigel, anything you want to say about malware before we move on?
Yeah, I mean, one of the things I guess that I'd love for attendees to understand is when you say malware, what exactly do you classify as malware or malicious in this scenario? I mean, now that we know it's not vulnerable code, what would qualify as malware?
That's a great question. Because malware is a huge category, and malware has been around probably as long as computers have been around. So I think I'll start by saying what we're not talking about. So we're not talking about malware that you might encounter in a phishing email that you click a link in the email and then oops, you downloaded something. Or perhaps you've heard of an attack called ClickFix, where you're browsing and perhaps you end up on an attacker-controlled website or something, and there's a pop-up and you click on it and oops, you get malware. That's not what we're talking about. So what we are going to talk about today is malware that comes through open source packages and repositories. So typically these are, a JavaScript or Python related package. Those are the most common interpreted language components that software engineers, or these days, honestly, anybody who's using AI and building applications, that you're pulling from the internet, pulling from a project, those can come about in several different ways. So we talk about malware that is an account takeover, or ATO. We had a lot of very famous ones in the last year. Perhaps if you use Axios or Chalk and Debug, you heard about threat actors taking over those projects and pushing malicious versions. So an account takeover is a genuine, legitimate, safe project that a threat actor somehow managed to get access to and then push their malware. So that's the famous version, and it's what a lot of the defensive measures have been created to protect against. And then the less famous, but just as, if not more dangerous, are typo squats and dependency confusions. And so those essentially are doing the same thing, where they're trying to trick you into consuming a package that looks legitimate, but in fact has been always owned by a threat actor and was always intended to be a vector to attack you. So we see a lot of threat actors using the typo squat tactic, where what they'll do typically is they'll fork an existing reputable open source project that, we see a lot of things in Tailwind, a lot of things that target cryptocurrency developers. So they'll fork those projects. They'll create their own version that, line for line has the same code as the original version. And in many cases, the README is exactly the same. The repo looks exactly the same. But what they'll do a couple of things differently. They will name it something that actually might be a little bit more logical. Maybe you've noticed a lot of open source projects don't really get named something that you might do a search for. So they'll pick a better name for it. For example, there's one where the legitimate project was just called, I think, Web3. And it wasn't like the Web3 project. It was just Web3. It was, in fact, a parser. And so the typo squat version was called Web3-parser. Oh, okay. Well, I know what that is if I look at the name. And they'll do other things that come from the SEO optimization to make them more likely to get pulled up into searches. There are lots of things, unfortunately, that you can do to artificially inflate downloads and forks and stars. And so they'll juice these projects and make them look legitimate. And then they'll start, getting them out into the community. Oh, I guess the other difference is they put malware on them. So one is that they do SEO, and the other is that they put malware in them. Yeah, so I think a lot of people are under the impression that a typo squat is something easy to spot. It's a literal typo and you'd have to be, kind of dumb or not paying attention to consume them. But honestly, it is a sophisticated form of social engineering, and many threat actors are really good at creating these, and they don't get taken down off the repositories as quickly as an account takeover. Because with an account takeover, if the Axios project gets hacked, everybody knows and everybody's complaining and the maintainer is complaining and it gets, fixed rapidly. But with a typo squat, there's nobody complaining about it. Nobody was had their, project, locked out or something like that. And so these things can persist. They're a little bit harder to discover. And unfortunately, places like NPM are understaffed and don't remove them as quickly as they should.
Amazing.
That was a long answer to your question.
No, that's a perfect answer, and actually on that topic, as I imagine most people who are watching this webinar right now are software developers or working in a security adjacent role to software development. More and more of us are using AI technologies, Claude Code and the likes, or Codex, for generating code, and that's fine. There's actually inherently nothing wrong with that out of the box. But AI makes mistakes. Does it, in the real world, pull some of these Typosquatted packages, or can it tell the difference between a legitimate package and a fabricated package name?
Well, short answer, yes, AI can pull it. And short answer, no, it can't always tell the difference. In many cases, and sorry, real quick, Claire, can you unshare the slide since we won't need that for a while? Thank you. Okay. So what we've seen is a few things. One is, first of all, the AI code assistants are typically not trained to recognize malware. Now, they may recognize, we'll say, like abnormal behavior with a dependency, but they're not very good at spotting malware. And so that's one factor. Another is, unfortunately, these AI code assistants do often hallucinate dependencies, and they'll add something to your bill of materials that doesn't actually exist, and you might not catch it. When you're doing your code review, it looks like a legitimate thing, and unless you click in to look at it, you won't realize that it is non-existent. And so, what threat actors are doing is they're taking advantage of what's called, these hallucinations by a tactic called slopsquatting. And what slopsquatting is it's kind of like the, the cousin of a typo squat, because it's doing the same thing. It's a malicious package that has taken advantage of, a terminology mistake of some kind. And so threat actors, and we have several examples of these right now we can talk about, we can get into Welldropper, but they will take advantage of these code assistants hallucinating dependencies, and they'll say, oh, I think these are the things that, an LLM might hallucinate. And so they'll just publish a whole bunch of packages that they think will match up with the hallucinated titles that an LLM might pick. And so, are these things that the average human might choose? Maybe not, but we're moving very rapidly toward a place where the average human or the average developer isn't really the one selecting the dependency, right? And so if you're a threat actor and you're looking kind of into the future about what you can do to, keep your pipeline of victims churning, targeting AI is a good strategy. So we saw a campaign last week. My co-founder, Paul McCarty, who's pretty experienced in the NPM malware world, noticed that there were a lot of new packages coming into NPM. They all bore similar signatures, and they were all these AI slop squats. And as far as we can tell, they were kind of generally kind of targeting a mobile SDK ecosystem. But over the course of 3 days, this one threat actor pushed over 1,000 packages into NPM that all kind of bore the same characteristics. And we were able to connect them to each other because, just like with, regular application infrastructure, threat actors have infrastructure also. And if your application needs to talk to the web, well, you're going to have a domain and you're going to have a URL and everything. And so threat actors use this infrastructure, not so much to, I don't think we could go as far to say hosting the malware, but it's a place for them to exfiltrate your data. They want this malware to steal information from you, or cryptocurrency often is another thing they're looking to steal, but the information they want is your credentials. And actually, I've got an example of how we can sort of pivot across different, I can type and talk at the same time. There we go. Can you see that, Nigel?
Yeah, I can see it. Perfect.
Yeah, this is just an example of how we can, as threat researchers, we can observe the infrastructure that the threat actors are using, and then we can use that infrastructure to say, ooh, can we find more examples of where they are acting? And so here we have what we would call a threat graph visualization. All these circles are malicious packages that came from this campaign. And we can see that they're connected to domains, and often the domains are connected to other packages that are being, served by that particular domain. So we've got 1, 2, 3 domains that are easily visible here. And, some of them only have a handful, 5 or 6 packages associated. This one on the bottom, I don't know how many that is, maybe 20. And then we can see we also have, a domain up here that's serving another from a different, back end. So this is a very common thing that we see in the threat research world, where we discover one malicious package or a handful of malicious packages. And instead of then having to go hunt, kind of by hand for each of them, we can pull them apart and see, okay, who are you talking to? Where are you exfiltrating your data? And then we can pivot across that and find others. So this is just one example. Sometimes they're much bigger than this. Sometimes they're much smaller, but this is pretty typical. What's interesting about this Welldropper campaign that we found last week is they spun up, nearly 1,000, if not more, independent GitHub identities and NPM accounts. And so, those all look unconnected. But then if you take their infrastructure and you can connect them by their infrastructure, you can see, oh, okay, we see the shape of this. This is all one related attack.
Yeah, and one thing on this, because obviously you have all this rich indicators of compromise related to the incident. And I don't know now in this case, is the attacker, because obviously they have a desired outcome, whether that's, exfiltrating credentials so that they can sell it on some sort of black market, or maybe they want to be paid out in cryptocurrency for some return of something. But in this scenario, can you tie it back to something like a crypto wallet? And if so, does it tend to just be one wallet tied to all these packages as an outcome thing, or what are you
so in this particular campaign, the Welldropper campaign, it wasn't tied back to a crypto wallet, but there is a .ru domain associated with all of these. And there's some other indicators that we can't share because we don't want necessarily the threat actors to know what info we do and don't have. But we do have evidence that the actors in this particular campaign are of Russian origin. So not necessarily state-sponsored, but there's some overlap with a campaign that we saw earlier in 2026. With blockchain, there's a couple things that we see with cryptocurrency related to malware. Number one, as I'm sure everyone who's heard about North Korea and malware has perhaps heard, that they really like to steal cryptocurrency. They are using it along with the paychecks that they glean from an IT worker scam to fund their weapons development program. It is their economy. So that's one element where we see crypto, in relation to malware. But in the other, they have, in the last year, maybe longer, they've been using blockchain addresses as part of their infrastructure for exfiltrating data. And the reason that they do that is because it's difficult to see those transactions as malicious traffic. What our traditional security programs are looking for is mass exfiltrations of data, but the blockchain transactions that happen. So the transaction itself is immutable, but there's a memo field on the transaction, and you can change the memo field. And so they'll change the memo field and send data that way. And it's very good at evading detection. But what we've seen, in particular, North Korea uses this technique a lot. It's called ether hiding. They will reuse their infrastructure. And so with other campaigns, including one called Pollen Writer, which we can talk about some more, we have been able to establish that a new bit of activity, a new piece of malware is associated with North Korea because they're reusing these blockchain addresses.
Yeah. And one thing on there is like, I see it coming up more and more as a behavior that's happening is in the past, maybe you successfully exfil you find credentials. So you find the credentials on an endpoint and then you send them directly to a C2 server. And the idea there is, well, if I just blocked egress traffic, you couldn't send credentials to an external endpoint outside of that organization. And obviously they come up with smarter and smarter ways, like talking to trusted domains. Maybe we see here with like GitHub Actions, so that they can create a GitHub public repo and then publish the stuff on that. And either way, they got it.
A lot of traffic to Vercel endpoints. Vercel endpoints are pretty normal.
Yeah, and in those scenarios, do you try when you're doing this sort of, for people who don't know open source malware, when you're doing these write-ups and you're saying, this is the attack, this is the behaviors that are going into it, do you also tie into things like the GitHub repositories to say, here is how they're achieving that? And would that show up also in something like that attack graph visualization you saw earlier?
Yeah, it's pretty interesting. I don't have an example off the top of my head that I can pull up to show the watchers, but essentially there are definitely campaigns that are different from the one that I showed, where they do use or reuse a GitHub identity. And so you can use a GitHub identity or an NPM user account, much in the way that I kind of showed you can pivot on domains. You can use those to say, okay, well, this identity, it published this malicious package over here. I wonder, did it publish other malicious packages? And in fact, that's something that we saw with the Axios compromise back in March. The maintainer who owns Axios, his identity was used to publish two things. One was an updated version of Axios that added a new dependency. So they didn't actually add any malware to Axios. But the other thing that they did, that new dependency that they added to Axios, was a crypto.js something file. And that's actually what had the malware in it. And so if you were looking at the Axios package and you were scanning it for malware, you never would have seen it. All you would have seen is, oh, there's a new dependency. Okay, people add new dependencies all the time. But if you pivot on the maintainer name, you see, okay, there's actually this new package from this maintainer. This new package is full of malware and it's being used as a dependency. That is a tactic that we're seeing more and more from threat actors when they either do an account takeover, like the Axios example, or they publish their own packages. Some of the packages will be benign, and that's an intentional evasion tactic. We saw an example a month or two ago where the threat actor did a takeover, published a whole bunch of malicious versions, and then they actually pinned all of those malicious versions in all the packages that person owned that were dependent on it. So you kind of have this like spider web of lots of benign things that, again, when they have a malicious dependency, your scanners probably aren't going to pick it up. You're probably not looking all the way in your dependency tree to see that. And then a little bit of malware over on the side. So they're counting on that, evading your detection.
And that's a really good point around evasion, is like I always hate saying it, but whenever we feel like we've solved two problems, the idea is that the adversary is always 3 steps ahead, and that's the logic we have to fight against as defenders. But, for a lot of people out there, we were told NPM in version 12.0 or whatever was a major. They were going to disable a lot of those pre-install, post-install scripts that we saw by default were enabled. And that's what happened, you mentioned there with Axios, where they didn't have to put the malware in the actual package itself. It was referencing something else which had the malware. But if those sort of hooks are disabled by default, how are these adversaries still so successful? Are they adopting new techniques? And can you think of some
Well,
maybe?
good questions. So to kind of explain a little bit about NPM and NPM version 12, they came out with the announcement, I think in late May, early June. They said they were going to be making some major changes in the next version of NPM, that's V12. I will say all of those changes are good changes in concept. One of the changes that they put forth in version 12 is the lifecycle script. So that's the pre-install script, the post-install script. They have been on by default for the history of those existing, and going forward in version 12, they are off by default. And then the concept is the developer, or however your policies, work in your organization, you turn those on individually as you need them. The reason that this change was made is because a lot of malware is designed to fire when a pre-install or a post-install script runs. And so it's kind of that auto installation thing. Now, here's the challenge. A lot of JavaScript needs its buddies. It needs all the infrastructure that goes with it. And if you are turning off those lifecycle scripts, in all probability, some of the things that you're consuming just won't work at all. You need those lifecycle scripts if you're running something locally. Now, you can kind of get away with turning them off if they're running in CI. You don't need them because you have CI to do all that for you. But a lot of JavaScript packages run locally. And so what we're going to see happen is if it's one of those packages that just won't function without the lifecycle scripts, okay, you're going to just turn it on every time you realize you need it. And at some point, rather than it being an intentional thought of, I'm going to turn this on because I've screened the package and it's safe and I need the script on, maybe you do that 10 times and you don't run into any malware, and then you just start turning it on every time and you don't look at it. So I think the intent was good with what NPM did there, because we are definitely seeing that as a common way that threat actors make sure that the malware gets deployed. But the Welldropper campaign didn't use pre-install and post-install scripts. So whether you turn it on or off, it's not like a guarantee that it's going to save you.
Yeah, and actually on your point there is like around version 12 specifically of NPM, because I know there's a lot of other ecosystems as well that either also have similar problems or don't have this problem at all. But in regards to NPM, do you find that there's pushback that people aren't upgrading to version 12 to solve this problem? Or to your point earlier, they are on the latest version, but they simply disable some of these measures because it's a breaking change. It's something that's
candidly, the answer is worse than either of those options. Most people are nowhere near latest version on NPM. We see version 8 and 9 floating around all the time. So I think, like a lot of changes, this requires people to decide to upgrade. And there's certainly a lot of people who have just decided historically not to upgrade. They haven't been forced to upgrade. And if you decide to upgrade to version 12, it's going to have breaking changes as a result, right? You're going to have to go through and fix a lot of stuff. So yeah, to your point, in order for this feature to be effective, you have to upgrade, you have to be prepared for it, and you have to have a process to decide, how are we going to handle, deciding when to turn on these lifecycle scripts.
Yeah, and like even you've mentioned there, like the latest campaign of one specific campaign have moved away from this altogether as an evasion technique, or they don't need to worry about it. But since I'm just hypothetically, mentioning, large regulated bank using older versions of software and do not use.
No, never.
Yeah, there might be one out there doing that. For that reason, the adversaries don't really need to change their tactics and techniques much, because it seems that, there's been, ever since Shai-Hulud got open sourced, it seems like any sort of script kiddie or person out in the wild could take that script and modify it for their own use case. And a lot of the assumptions in version 1 of Shai-Hulud, other than the fact that if you made no changes to it, probably all your DNR tools probably detect it today out of the box when it executes. But you could grab that same code and you could absolutely throw it back into a registry, no different to Team PCP. And you're saying probably a lot of organizations aren't still prepared for that, as in the same attack can be used over and over again with little to no.
I mean, just a totally different example. I used to work in Kubernetes, and we've seen multiple times with Kubernetes goes through its progressions, and at some point there will be a version that is sunset and will not be supported anymore, or a component gets upgraded and it's breaking changes backwards, and every time that happens, there's emergencies in organizations that are like, oh no, we have to upgrade Kubernetes. We haven't touched it in 3 years or something like that. So the reality is, like, a lot of organizations are not running on the latest versions of software, and that's not necessarily bad. It's just how it is. You don't upgrade it unless you need to. So yeah, threat actors don't have to completely innovate their toolboxes in order to compromise people. With the shy hallude stuff, I think this is probably a good time to talk about that. Oh, I see a note in the chat. I see we have a comment or a question from Grant around the NPM 12 issue. How do you navigate the trade-off from developer noise as the norm versus malware protections with fire with low detection rate? Yes. Security protections become self-defeating. If they stop or slow down the developer, they just get disabled. 100%. That's exactly what I'm saying, is it's going to become noisy if every time you have to install a package, you have to go request something from the security team, and it turns out that everything was safe. We've seen the exact same thing with software vulnerabilities. You have a really high false positive rate, people stop trusting the results and get into trouble. So I think this maybe is a good place, before we talk about shy hallude, to talk about defensive measures so you can reduce that noise. What do you think, Nigel?
Yeah, I think so. Absolutely. And actually, cool. On that, just around like developer productivity, there is an age-old question, and I'd love your opinion on it, because I feel like there's no actual right or wrong answer, which is around dependency version pinning versus just updating.
That was my first thing on the list.
So I'd love your take on it. I mean, just in simple person logic. If you pin to an old version, you're good because you're probably not going to get a compromised package. That's sort of the basic logic. But the other person would say, always upgrade to latest because you won't get vulnerabilities, or at least a vulnerability should have been addressed in the latest version of that package. What is the right or wrong answer in this scenario?
As you said, there's no right or wrong answer. There's only answers. So dependency pinning generally is a good practice for avoiding malware consumption. It's not going to keep you completely safe, and here's why. This comes back to direct dependencies and transitive dependencies. So you can pin your direct dependencies, but if your direct dependencies contain transitives, which especially if you're in JavaScript, you probably have 1,000 of them, very often those transitive dependencies will get pinned to version x.x.x and higher, right? So even though you may not be actively upgrading the dependency that you chose, if a threat actor compromises a downstream dependency that your dependency is set up to call in some way, if it's calling the latest version of something, then you still do have the chance to consume malware that way. And that is a very challenging situation to be in. But I would say in general, most organizations are just fine pinning and then making an explicit choice to upgrade, because in general, you can't rely on semantic versioning to guarantee that you won't get breaking changes when you upgrade, right? Like, just because it's a minor version change doesn't mean you won't introduce breaking changes. So generally, I'm a fan of the version pinning. It's going to be a smaller number of shops that care about being on that latest version 100% of the time. Like, most engineering policies don't want you to do that because you want to make sure that you don't break your app. Now, the argument that you'll get from people, especially security people, is, but what if there's a vulnerability and I have to upgrade to latest? So this is the, like, again, there's no right answer. There are things that we do to remediate vulnerabilities that make us more susceptible to ingesting malware, and always upgrading to latest is one of those. So if you have to upgrade to latest for a vulnerability, odds are good you're not going to be doing it like so rapidly, so quickly that you're going to be ingesting that malware. You know, are you going to be upgrading to latest the second that the new version comes out? It's unlikely, just because, again, you're probably going to be going through that vulnerability management process and identifying the ones that need to be upgraded. And okay, we've got a critical in this library over here. Now we need to see what the breaking changes are. Probably by the time you get around to going through your security processes, it's going to be safe to consume, because usually if it's an account takeover, they tend to get taken down pretty quickly.
Yeah. And out of curiosity, when it comes to malware that yourself and Paul and team are discovering at Open Source Malware, is it always the newest thing? Or are there cases where if I pin to, or not even pin, but I'm just happen to be already using an older version of a dependency, are sometimes those ones compromised? And if so, what is the general logic you find in this scenario?
So with an account takeover, again, that's when a legitimate compromise package has been compromised. Most of the time, not always, it will be the latest version is malicious. And then there will be like this race, you know, to get it pulled down before people consume it. And so you may see, like, we saw this recently where the maintainer thought that they had kicked the threat actor out. And so you saw malicious, malicious, good, good, malicious, malicious, good, good. And they just kind of like stacked. That's not super common. Unfortunately, what happens a lot of the time with account takeovers is the maintainer is locked out completely, so they can't push a safe version. So in many cases, the latest version in an account takeover scenario is the malicious version until it gets pulled down. Sometimes the threat actors will be a little bit more clever, and they themselves will publish a malicious version and then a safe version, and then they will pin everything to the malicious version. And so if you're just scanning the latest version, it'll appear safe. But again, if it's an account takeover, the maintainer will be yelling at it. If you have a cooldown policy in place, you know, of maybe 3 days, it'll get worked out by then. Not a guarantee, but probably. Now, if it's a typo squat, oh, sorry, go ahead, Nigel.
No, I was just wondering on that topic, because you mentioned something about when the account gets taken over and you lose access to your account. So I'm trying to think of it more from the attendee's perspective, that, and also for myself, is if, you know, I maintain 2 software dependencies, and one's on NPM, one's on PyPy. So I have an account on NPM, and I own, well, I assume I own, I guess no one really owns anything, but, you know, I maintain
hypothetically ownership, yeah.
Hypothetically own it. So if my account gets taken over by a bad actor, and then, well, I guess it's the JavaScript NPM package management, do they then kick the person out and then no one owns the account, and then it's NPM that are freezing the accounts? Does that happen? And if so, what is even, I know this is slightly off topic, but how long is it before maintainers allowed to actually push any code again on their project? Are they sitting there for a day or two just wondering, I guess I can't do anything for the time being?
Yes. The short answer is yes.
Okay.
Usually what happens, and this is NPM specific. Most of the malware we see is NPM. That's not to say that's all of it, but we just see a lot of NPM malware. Usually what happens is, in the case where the maintainer gets locked out, so the threat actor has in some way, this happened actually last week, a maintainer named Jason Ray, I don't remember the names of his projects, Cacheable and Kiwi or Kev, I don't know how to say it. Yeah, he got his account compromised. And actually what happened, he lost access, I believe, to both his GitHub and his NPM account. And it turned out that the attacker had stolen his PAT. So the attacker got into his accounts, changed passwords so he couldn't get in, and then published malware. Now it got reported, and NPM froze the account. NPM didn't then work directly with Jason so that he could come in and publish a safe version. And so he was locked out of his account for at least 12 hours. I think it might have been a little bit longer. They weren't responding to his communications, which in some ways is understandable, because if a threat actor has taken over your account, what's to say the threat actor didn't also get your email, right?
Course,
So
yeah.
how do they know they're talking to the right person? So this is definitely like a nuanced, challenging situation that I don't envy NPM for trying to figure it out. But Jason actually took to Twitter, or X, whatever it's called now, and is posting, "Hey, this is what's happening. Don't consume my stuff. I'm sorry." And then he, was trying to get a hold of NPM throughout this and tagging them and, asking for help, asking for people to make connections. Eventually, he did get his access restored. We don't know the full detail of how they might have vetted that he is, the genuine person. But this is kind of the pattern that we tend to see a lot with these account takeovers and it's changing. NPM and GitHub are adding features that make it more difficult for a threat actor to totally take over the account and push malware. So they've done some things with like password resets and things like that just make it harder to lock out the maintainer. But the reality is, once malware is detected, their policy is to freeze the account so that nothing gets published.
And that brings up kind of two questions then. Is the first one is, on a given day, a really bad day, where we're talking about this really unfortunate scenario, genuinely unfortunate, where both for NPM as the registry, but also for the maintainer of the project, they don't really know how to interact with each other until this thing is mitigated. But in a really bad day where 25, 35, 45, the number keeps going, maintainer accounts are compromised all of a sudden in a kind of a doomsday scenario, how does NPM work in that scenario with all of those maintainers? It all sounds like it's a very manual process. It's like you're going in and you're mitigating, cleaning up, making sure everything's rotated, and that you can hand over your account back to the maintainer again. Is this like a genuine existential problem now for projects or registries like NPM, that this is going to keep happening and eventually there's going to need to be some sort of automated system to handle this? Because
well, what we know is that NPM's security organization is understaffed, and responding to a single incident, well, I guess it wasn't a single. So with Jason last week, not only were his accounts compromised with malware, but what's called an NPM worm was part of that malware. And so anybody who was compromised by his packages, then that worm propagated to other packages. So over 400 packages were compromised in total in a single day last Tuesday. So that's not a worst case. Honestly, we've seen a lot worse, but it's pretty bad. So yeah, the accounts get frozen. NPM does what it can to, I guess, stop the bleeding, but they are slow at catching up. And yeah, I mean, maybe to some extent, some automation needs to be added, but we're just not seeing Microsoft, because that's who owns NPM. We're not seeing them put resources behind rapid response to these cases.
Yeah, so
I don't have a better answer. It's not great.
It's a perfectly valid answer. And it kind of brings up the question then about, well, what are yourselves doing that Microsoft aren't doing? So, I'd love, in a perfect world, we say Microsoft have just figured out all of the security problems in GitHub and NPM. And that we know that world isn't real right now. So incidents happen, people lose access to their account, and that's a real world. So yourselves, thousands, tens of thousands of packages are getting flagged as malicious. How are you doing it? Are you doing it where you manually read through source files and say, I found something bad? Or are you doing something that's more efficient and also timely? Because I think the big problem here is it is the time to response, isn't it? Where it's, if an account has been compromised and a package has now contained bad code, it only takes a second or so for me to download that package. So, solving
time matters. Yeah.
Exactly.
Well, before I talk about what we're doing, NPM has implemented pre-publication scanning according to their blog. We're a bit skeptical that it works because, again, we saw some pretty big attacks last week where it went through, but we would like to see them like genuinely not put us out of business, but, make it so that we don't need to be as on it by catching the malware before it ships. A lot of other registries do this. This is not innovative to do pre-publication scanning. OpenVSX has made a lot of investments there. We're seeing PyPy doing more there. But on our side, we bring in our data from 4 sources in no particular order. The first one is community. So anybody who creates a free account on our platform can submit a report of malware that they found. And so that comes from, the average community member all the way through researchers. There's people looking for this all the time. So if they find a malicious GitHub repo or a malicious PyPy package, they can submit a threat report. We'll analyze it and validate it and publish it so that people know about it. We also consume the other data sources that are out there because somebody else may find it before we do or before a community member does. So, there's lots of vendors that are doing research in this space and publishing about it. We do our own scans and automations. So we're keeping an eye on things that change in the registries and looking for malware. As I mentioned earlier, my business partner, Paul, is extremely experienced in, the malware space specific to interpreted malware. And so he's written some, mix of open source projects and proprietary things that analyze, for indicators that malware is there. And so it's not just looking at the pre-install and post-install scripts, it's looking for certain behaviors. We're seeing, for example, North Korea really likes to use bat files, and they make it very hard to, I guess, disinfect might be the good word. It just keeps firing until you can get rid of it. And then we do our own hunts. So a lot of the ways that we find malware is we go find the malicious GitHub account that it comes from, because if a threat actor is going to push malware to NPM, well, it has to come from somewhere. And often it comes from a malicious GitHub account first. So we're constantly looking at all of these things. Do we catch it all before it gets consumed? No. We're not there yet as an organization, but I would say it's happening faster and faster. So if you have a combination of tactics in place, you can avoid consuming malware without it getting too noisy for developers. I see there's something in the Q&A, so we'll pop over there in a second. So what I would recommend, and maybe this, what should you do on Monday? Great, perfect. That's what I was going to share. Yes, do dependency pinning. It's wise. If you have access to cooldown policies, you should turn on cooldown policies. So all that means is you wait a set amount of time until consuming a new version of an open source project. So pinning combined with cooldowns, that's really helpful. It's not going to catch all of it. It's not going to catch that malware that's been out there for several months, but it should slow you down just enough that you don't consume new malware. And then you should have internal policies to kind of like circumvent the cooldown if you do have an emergency and you need to upgrade. But those should be rare. It shouldn't be on the daily basis that you need to circumvent and like emergency upgrade. Using our threat intel feed, so we offer a free API. You can go use it to do a one-to-one check and say, is this malicious? Or you can pull in a stream of what we've validated already. We human confirm everything. And so you can get a high signal threat feed. And so if you combine, some of these engineering blocking mechanisms to just control what you're consuming, combine that with a high fidelity malware feed that lets you know in real time, no, this is dangerous. No, we haven't seen this one. It might be dangerous, but we haven't seen it, so it's probably okay. This came out 6 months ago. We haven't flagged it. That can really, through automations, help you reduce the chances of consuming malware without adding a lot of noise and friction for developers. And that's what I think is really important, is you have to make the right thing easy. And if you make the right thing easy, you have fewer people trying to get around it and do something else. Now, there's a lot of other things I would tell you to do on Monday, but those are the 3 that I would tell you to focus on.
That's amazing. I actually think that kind of brings us up on time. Claire, you can let us know if we're tight, or if there's anything else coming up in the Q&A.
Yeah, thank you both very much. I think we're okay question-wise. They were both really good questions. That was really insightful. Thank you, Jenn. Thank you, Nigel. Obviously, cooldown policies, policy management, dependency pinning, some really interesting insights there at the end. I'm sure you're busy, Jenn. The frequency of dependency attacks, I think we've all noticed, has increased. So I hope you get a chance to go out on your bike and do something fun.
I'm going to go get a bagel soon. Exciting morning for me.
Good. Yeah, so thank you both. Before we just log off, we have Cloudsmith have our monthly Cloud Native Digest. It's basically like a curated newsletter full of trends, news articles, software supply chain security, artifact management. And Jenn, I'll maybe let you talk about the next one. Oh, we have a little...
Yeah, just dropping a couple things in the
Perfect.
chat. So first off, I shared a research blog that we published about that AI slopsquatting campaign that we saw last week. We also have one about the NPM worm that Jason Ray was the victim of. So I'll go ahead and share that one as well for anybody who wants to learn a little bit more. So NPM worm. And then I also shared the homepage of our website, which you can see the latest malware that we've added to our feed. You can see it, you can filter it, you can, look specifically for, VS Code malware. And then you can sign up for a free account and you can get a free API and you can pull it in yourself. We believe really fundamentally that everyone should have, the ability to know if something's dangerous. And so that's why we make that free.
Brilliant. Thank you, Jenn. Apologies. Google slide issues. I couldn't go on to the next one, but you've provided the links in the chat. That's great. Yeah, so go check out OpenSourceMalware.com. And yeah, thank you very much for joining us. I would also be remiss if we didn't mention that Cloudsmith actually just released in general availability our continuous risk detection and policy management as well. So you can go check that out as well. Okay, thank you both for your time today. Hope everybody has a lovely afternoon, morning, and we'll see you at the next session.
Yeah, it's been great. Thanks for having me.